Okay. So what I've done now is I switched to the previous settings, which basically means a smaller screen to code on with the previous bitrate and the previous keyframes and all of that. Um, no, I still see a black screen. So I don't know what it is now.
Oh, I see it
Oh,
now.
now I see it. Great.
Oh shit! You did it
Okay.
like a pro. Wow, that was not easy. So what changed? It was bitrate
Yeah,
and
just bitrate settings. Um, yeah, I don't know. Just bitrate settings and stuff like that. So we should be good now. Um, and hopefully that's the end of our streaming issues. Um, all right. So after about what 25 minutes of streaming issues, um, we are officially starting.
yeah.
um, so um, you want to do a quick well, first of all, the usual good evening, Stevens.
Oh my god. No, good morning.
Um,
I refuse to say good evening ever here again.
okay. So you want to do it. So today is session number
Nice.
9. Um, you want to do a quick recap on what we've done in the last 8 sessions?
8 sessions. Well, all right. So we are building a website called the Creative Network.
Mm-hmm.
So basically, um, let me try to make it short. So we want to build a platform for people to share their DIY projects, photos, and then have a way for people to comment on it and communicate like a
Yeah.
ecosystem, and
Yeah.
then potentially for people to link to other e-commerce site on where to purchase the parts that's required to do similar DIY projects, right? Such as battle stations, computer system, home offices, etc.
Mm-hmm.
So that's the idea, and we're building this thing from the scratch, full stack, client side, server side, database server, everything. We're gonna do it from scratch, right?
Mm-hmm.
So we settled on using um, React for our web client. Okay, we're gonna use GraphQL for our data API, and then we are also going to use um, AWS Lambda, AWS Gateway to build our photo upload feature.
Yeah.
Um,
And just I'm showing it on the screen. What is our new architecture? Um, and yeah, this is the new architecture here. Yep. um, so you want to talk a bit about the serverless part here, the kind of the serverless part of the system.
sure. So I think last week, this is basically what we worked on last week. We are getting to part of the core feature, which is the photo upload and the storage and how to access the photo, right?
Mm-hmm.
And then we have this architecture as you're showing here in my blog. Um, so basically, we want to have an on-demand photo processing system. We want to have the client to upload the photo and then store the original size in S3 without processing it,
Yeah.
right? And then we want to build another separate like access point where the client can make make requests on any size, and we will cut the original photo in that size as the client requested,
Mm-hmm.
and then we will, return the process photo and then store the recut size in our storage system, right? So that's the bigger idea, and then that is going to be done by AWS Lambda, and then yeah. So I think we are in the process of building that. In our last session, we have the Lambda function ready when we're using Sharp, the Node Sharp library to process the photo.
Yeah.
And then I believe we wanted to compile this in a Docker environment because it needs local extension, native extensions that only works for a Linux system.
Yeah.
And that's where we left off since last session.
Yep. Indeed. So,
Anything you want to add?
no, I think you gave a pretty good overview. I think one of the things that we kind of need to decide on is how do we move forward from here,
Mm-hmm.
and what do we focus on? Because as we kind of go through with working on the system and developing it more and more, we kind of need to decide what are we working on next. And again, because this is almost completely for educational purposes, then we basically can decide to work on whatever we want.
Right.
So here are the kind of next things we need to do. Let me try and open up Sublime here.
I remember now. I think last session we talked about using Terraform and
Yeah.
Docker to do the deployment process. So I think that was where we left off.
Yeah. So kind of to-do tasks that we have. So we need to compile Sharp and the Lambda function packages using native Ubuntu, right? We need to upload the Lambda function every time you compile. And we need so each of those is another kind of task in and of itself. So we need to compile Sharp and the Lambda function packages using the native Ubuntu. We need to upload the Lambda function every time we compile. We need to. So and here's the thing right now, right? So in terms of AWS, we have these resources. So we have a Lambda function. We have
the gateway, right?
Yeah. So we have the API gateway that will trigger the Lambda function. We need an S3 bucket to store the originals and the resized images. And we also probably need a CloudFront, in front of everything. This is to kind of cache the images and not hit the Lambda function every single time, right?
Okay.
So we still have all of this stuff in terms of infrastructure. So someone on live edu is asking what is AWS, and I'm pretty sure it's I don't know. So I don't want to be sarcastic. So AWS is Amazon Web Services, and it's basically what the cloud is. um, so going back to kind of what we need to do. So we have all of these dangling tasks, and all of these dangling tasks, they're there, but they're still you know not really kind of the core of the product. So we can easily put those aside, and decide we want to continue working on the core of the product, um, and we can also decide to say, you know what, let's work on those now, and move forward with the product after we have those. And I think after all of our discussions of personally you want to do DevOps, and your interest in Terraform, and how these things work, then I'm not opposed to doing this now.
Mm-hmm.
Um, but again, this is completely a matter of what we want to work on. So this is what we have. Um,
But I thought that in order for the photo upload to work, we have to compile it anyway, right?
yeah, but I
For us
mean,
to
we
be able
still
to.
have things to do before the photo upload.
But the
Things we can work
architecture,
on before the photo upload.
this architecture is not ready, right? We only have the Lambda function so far.
Yeah.
We still have to build the upload and the storage to S3, and the API that will process the original and go to the RDS.
Yeah.
Those components are not there yet,
No.
right?
Yeah. Those components are not there yet.
Um,
And again, just to kind of people that are watching, so if this is the architecture, then we have this part, basically this part of the architecture here, and all of these parts are missing. So we don't have the calling to RDS. We're basically calling our API and saving the photo. Oh, sorry, actually this part is here. Um, so this part is actually here. The part where we want a specific image, and it serves it for us.
um, so what do you think? I mean, I'm okay with. I know we're gonna kind of build every component. It's just a matter of time. And if you think that we can just build each component and then we figure out the DevOps and the deployment like together, because the Terraform and Docker, I imagine at least for Terraform, it's gonna handle multiple jobs, right? Instead of just deploying the Lambda function, it's gonna deploy like we have two Lambda functions at
Well,
least.
so Terraform is not actually deploying the Lambda functions. What if we focus on Terraform here? What Terraform will do is this. So we'll have create the S3 bucket for the images. Create the S3 bucket for the Lambda functions. So this
Right.
is for the source code. Create the API gateway.
Wow. Yeah.
Connect the API gateway as a trigger to the Lambda function.
Okay.
And create CloudFront and connect CloudFront as the I don't know how they'll call it, gateway to the API gateway. Well, I don't know if this is, let's say, entrance to the API gateway and the Lambda function. So this is a cache through. And this is what we're gonna kind of do with Terraform. And then we still need to so we still have Lambda here. So we still need those. Right?
Mm-hmm.
So even though we'll have the Terraform, we still need the other parts here.
What do you think? I mean, I think this is where I think I lack the experience and the expertise to kind of
I mean, let's
tell.
do the Terraform. Right? I mean, what do we have to lose here?
Yeah. I would prefer doing the Terraform. Seems like Terraform as the manager of the kind of the different moving components seems like a good idea to work on. Besides, I've never, it's something new to me, so
All right, so let's
makes it
do
really
this.
exciting.
And Creative Network Terraform. Right, and let's already open source that.
Oh wait, make sure you do it under the new GitHub.
Yeah. What is it called? The Creative Network, Full Stack Network. Right? It's here. It's this one.
Okay.
Okay, so let's create a new repository. Call it Creative Network Terraform. And this is creating the Creative Network resources. It's going to be public. We have Terraform. Yeah, Terraform. And license is MIT. And let's go ahead and create the repository. All right. So let's do this. And then here, instead of doing this, Creative Network Terraform, we'll do, so this is RF. So we're going to do git clone. All right. So what do we have here in git ignore? So we have tfstate, tfstate.backup. We have Terraform. And what I also want to ignore is terraform.tfvars. Actually, everything with tfvars I want to ignore. All right, and then we have a README here. And let's do this.
Are you doing README? Oh, wait a second. I haven't even SSH in yet.
Yeah, I'll give you SSH just a sec. So you can SSH now. And now we can start working on this. So first things first, have you ever worked with Terraform before, know about Terraform, or anything of that nature?
No.
All right.
The first time I ever heard the word was from you.
Okay.
That's about it.
So Terraform is basically without going to kind of the documentation and reading from the documentation. Terraform is a way to create resources in the cloud or on your virtual cloud in a way that is driven by code.
Okay.
Right. So think about the way you're doing it now. If you want to create a server, you want to remove a server, you want to create a load balancer, you want to change a security group, you go to the AWS console, you change something there, and then you're done, right? A few problems with that. One is this doesn't scale because you usually don't document it. Someone can easily go and revert your changes. And you know the problems with that, right? You can leave resources dangling,
Yep.
and like a whole lot of problems that when you're working alone on a big system or when you're working in a large team that a lot of people are kind of touching the infrastructure, then those approaches don't scale. Right? If you want to add a resource and you want to remove a resource, just going into the console and changing it and like tweaking or doing whatever just does not work anymore.
No.
So Terraform is a way to do that managed by code. So for example, if you want to add a bucket, then you create code to add that bucket.
Okay.
And once you create the code to add that bucket, then what happens is that it saves a state. And once you go and you change the code, for example, you change the name, it compares the resources you have online with your state, and then it figures out whether it needs to change the resource or it needs to remove that resource and add another resource in its place. Right? So it's smart
Okay.
enough to understand the
Okay.
difference between the two.
That makes sense. So my question here is, what if some other channel, somebody touched the resources through some channel other than Terraform? How would they handle that situation?
So what happens during the Terraform run? It refreshes the state from the state of the system online. So even if you
Okay.
go and as long as that resource is managed by Terraform, it will know that the current state that it's supposed to be in is not the state that it's in, and it's gonna tell you that.
Okay, so it will try to sync with the current state.
Yeah.
And that's actually running on AWS, for example.
Yeah.
Okay. All right. Got it.
All right. So um, Terraform can be built, in a whole lot of ways. But for now, we're really gonna start with, the bare minimum.
Okay.
Which basically means we're gonna start with a single file, and we're gonna work from there.
So Terraform is basically a cloud resource management tool.
Yep.
Yes?
All right.
No?
So we're gonna do main.tf here. And the first thing we're going to do is we're going to declare a provider called AWS, right? And what is the region? So we are in Oregon, so that's US West 2, right?
Okay.
Is it US West 2?
Yeah.
Let's see.
Infrastructure as code.
So let's see if, yeah, it's US West 2. It's US West 2. All right. So it's US West 2. But actually, you know what? Let's do it in, because I have no resources in other, then let's do it in US West 1. Oh,
Okay.
but I actually have it there. Um, Oh, okay. Anyway, let's start. Let's not worry about it right now. Okay, so let's do US West 2. So this basically initializes the provider. And by initializing the provider, what I mean is every time you do AWS underscore something, it's going to use this provider in order to initialize that resource.
Okay.
Right? You don't need to like go into the internals of this. All right, so now we are going to need, so let's go ahead to our notes and see, we need the bucket for the images.
We need
Right?
the bucket for the original and the
Yeah. So let's create a resource, and the resource is going to be AWS S3 bucket. And now this is the name. So let's call it images. Bucket is creative network images. Okay. And I want to show you something. So creative. So here is the AWS console.
Okay.
And what you can see is I'm searching for, sorry about that, just 1 second. Safari doesn't want to resize. All right, here it is. So what you see is I'm looking for creative network, and we have creative network uploads, which we created ourselves. So first thing, I'm going to delete this bucket. Okay, here, and then confirm. We don't have anything, super important here. One more thing is we can do is we can go here to our account, and we can. We actually don't have a Lambda functions, so that's good.
Didn't upload it. Okay.
Oh, actually, I'm not in Oregon. That's just a sec. So for Oregon, I need to go back. Okay, so we don't have Lambda functions. Wait, let's see. So we have so we have this one, so we can go and delete that. All right. So now we have, so
Nothing. We have nothing.
Nothing, right? Okay, great. So we're gonna call this bucket here ACL for this bucket. Let's not worry about ACL right now. ACL is gonna be private. Let's not worry about anything really. Versioning. So versioning. And this is going to be enabled equals false because I don't want versioning in this bucket. What else? So let's create a couple of tags here. And those tags are going to be name equals creative network images and environment. Let's say we have an environment right now, so this is going to be dev. And you know what? That's should be enough. Okay.
The version enable true bucket tags, creative images, environment, dev. Okay, so okay.
Right, so now eval. Let's do this. Photo and -p avi.
What is this
Terraform -v. Just 1 second. So Terraform O93. Okay, O93 is enough. So let's do Terraform plan now. Invalid client token, security token in the request is invalid. That's weird.
Where does it grab your credential? I mean,
I have them in the environment. By doing this eval -p, I have those in the environment now. This exported the AWS token and the AWS access key to my environment.
Okay.
All right. So one thing, let me just verify that. So I do see access. Oh, okay, I see. But I do have an access key and a secret. So let's see AWS and. Okay, so let's do another thing. So let's do this. And plan. Let's see if that does it. Okay, great. So one thing you can see now, and check this out, right? So what you can see is you see this plus in green.
Mm-hmm.
What this says is like I'm supposed to add this bucket, but it's not there. So you see the plan is 1 to add, 0 to change, 0 to destroy.
Oh, okay. 1 to add, 0 to change. 0.
Right?
Okay, interesting.
So check this out now. So Terraform apply.
So plan is just like a dry run, right?
Well, it's not really a dry run rather than a plan. You know what I'm saying? All right, so go here and refresh. Why it's happening? All right,
Now
creative
it's gonna
network
add.
images.
Oh, wow.
All right.
That's Terraform's awesome.
And now if we do plan again, you're gonna see. Oh, you see this? So refreshing state, and you see no changes. Infrastructure is up to date. But
Okay.
if I change this to bucket equals, I don't know, 2, and I do plan, then what's going to happen is one of two things, right?
Mm-hmm.
So check this out. So you see this plus and minus?
1 to add. Oh, plus minus. What does that
Right?
mean?
So that means that it can't change the resource in place. You see this? Forces
Okay.
new resource.
So it means that it's going to create a new one, but it's not going to
Exactly.
delete the old one.
No, it's going to delete the old one.
It's going to delete the
Yeah,
old
that's
one?
why it's minus plus. Right?
So in a production environment, this would wipe out all the data.
Well, yes and no, because you can put protection in place that it will not delete existing buckets with like data in them, right? But
Okay.
I want to show you something here, right? So this, you see this forces a new resource, right?
Yeah.
But if I don't change this and I change the tag, you see, and I do plan, then what's going to happen, it's going to change the resource in place. You see here? So it's yellow. And it says, hey, tags with name was creative network images. And I'm going to change it to creative network images 2.
It means that it would just simply change the tag without touching other stuff.
Exactly. So it's smart enough to understand what in the resource is able to change in place and what's in the resource is not able to change in place.
Why? What? Okay. Okay. All right.
And that's, AWS limitations. For example, let's say you have a Postgres database.
Mm-hmm.
You can change the instance type of the database in place.
You cannot.
No, you can't.
Okay.
Right? So it's going to delete your old database and it's going to create your new database. So for these things, Terraform, you can't do it in production because it's going to basically destroy your old database, right? So,
right.
I mean, Terraform is really, really good with like having something, but it does not, totally free you up from like writing scripts and doing things, that are more fit for a production environment.
So it's kind of dangerous unless you put protection in place. Like a single typo could have wiped out your production data.
Well, again, that's why you do plan before. You look at the plan, you
Hmm.
reason about the plan, and then you apply it. You know what I mean? It's not
Yeah.
like you do apply and like for on your entire production environment, right? I mean, think about it. For right now, the workplace that where I work, we have Terraform for our entire environment, and we have, well, I don't know the exact number, but we have a lot of servers and a lot of resources. So,
Hmm.
for example, like just this Monday, I had, you see this like one to change, one to add that we've had here. So I've had on production 270 something to add, 248 to destroy, and 3 to change, right? So I had to go through all of these, make sure it's not destroying something that I need, make sure when it's changing that it's changing it in a way that it's not going to create downtime.
Hmm.
So when you do like big refactoring, you still need to look at all the resources, you still need to execute plans multiple times.
Yeah.
But I mean, just imagine doing it without Terraform. It would be like impossible. It would take days,
Yeah. Two
so
hundred something. That's crazy.
yeah, so I mean, think about it: destroying all the target groups, destroying load balancers, creating new load balancers, assigning Route 53 records to those load balancers, creating new ECS clusters,
Hmm.
renaming things. I mean, it will literally be a checklist of 500 things, and it will take days to do it with the console, just days. And the process will be like 50 times more error prone than to do it with Terraform.
Right.
Okay, so
Right.
now we have this. So we created the S3 bucket here. What we need here is to make sure we have the correct ACL. Right now, the ACL is private. All right, so we're going to create the S3 bucket for the Lambda functions. So
What is
let's
the
do
ACL?
ACL is access control, and you can say who can read, who can write to that bucket. Just permissions basically. So this is Lambda functions, and this is this. So this is creative network um, network Lambda. Lambda.
So
Yeah.
i- the Lambda functions and this is just a name for.
Yeah, this is the name of the resource, and this is the actual name of the bucket.
Oh, okay. So the name of the resource is only for Terraform.
Yeah.
And then the Lambda function, they are stored in S3 buckets, basically.
Yeah. All right, so we're going to create a new bucket for the Lambda functions. All right.
Cool.
Here, we need to create the API gateway. So for that, I actually need Terraform API gateway. There it is. AWS API gateway description. So what do we have here? So API gateway. Resource AWS API gateway. So what does this actually create? The list of binary media types supported by the REST API. By default, the REST API supports UTF-8 encoded text payloads. So read resource ID. What else do we need here? So let's see what we have here in the model. Model, and then the REST API is ID, user, JSON schema. Okay, so this is the model for the API. Got it. Okay, so let's start with creating the API. here.
So why do they call it API gateway model?
Well, it's different things for different, so so let's do this.
REST API.
And so API gateway. So let's see what we have here. API gateway. I think this is deployment. API gateway integration inside your REST API, which is in turn depends on API gateway method. REST API, and then the resource, REST API ID, and then the parent ID, and then we have another resource with the method. All right, so let's do this. So this is, let's call it resizer. Let's call it image resizer. All right. Now let's execute the plan. All right, so this should create a new bucket and then the API gateway. So you see this?
Okay.
So 2 to add, 2 to change, 2 to destroy.
So API gateway REST API, AWS API gateway REST API. These are built-in name for the
Yeah, you see
particular
I'm
resource.
like in a Terraform documentation. These are all built-in resources. So you see you have Route 53, you have gateway, you have EC2 instances, you have, a lot of things.
Got it.
All right, so this created the things. So if I go here and I go to API gateway, I should have an API gateway here. So we see the image resizer here, right?
Okay.
And you see there is like a default action, no methods here. And if we go to the previous one, which we created by hand, you see it have the upload processor Lambda. This is a method, right? And then the method request integration to a Lambda proxy, right?
Mm-hmm.
So you see all of this. We still need to do this with our Terraform.
Okay.
All right, so we have create the API gateway. We have that. Now we need to connect the API gateway as a trigger to the Lambda function. All right, but at this point, I think we still need here. Make sure you can deploy to that S3 bucket. And for this, we need these. Where is the make sure part? Here. Right, so we still need to do the compile sharp and lambda in order to get the rest.
Okay, yeah, this is where we need to compile it.
Yeah. So, I don't want to go all out on the Terraform things before, before we have the, the sharp resources compiled. So what I want right now is to make sure I can deploy the Lambda function and just 1 second.
Maybe we can just compile the Lambda now.
So
is that what you want?
No, let me kind of try and find my words here. What I'm trying to say is that I don't want to go all out on the Terraform part of things before I know I have the Lambda function deployed to the S3 bucket after
All
it's
right.
compiled.
All right.
And then what I can do is I can upload it and I can terraform the rest of the system and output my API gateway URL from the Terraform run, and then I can test it right away. You know what I'm saying? So like two things kind of need to meet and converge before we can like continue.
Yeah. So why don't we just compile the sharp?
Yep. All right. So first things first. Let's do this. And here and here. So before we do that, let's, for our readers, so let's do this. Just 1 second. So let's do this here. Great. So and live streaming all of it, we need to create some AWS resources in order to deploy the application. We decided to work with Terraform in order to make that happen. This is open source, just like the rest of the system. All right, so let's do this. And one very important thing here, right? So I never, ever, ever have my keys inside here, right? But
what do you mean?
should, like your my AWS keys, right?
Okay.
You don't see them here. So what people usually do, and I've seen that happen, is they'll have like here they'll have AWS access key equals AWS blah blah blah, I don't know, something something something, and AWS secret, and then they'll have this, and then they'll commit it to GitHub and get their account hacked in like 3 seconds.
All right. Okay.
So it's really important to make sure that it's really important to make sure that you don't, commit those. And another thing is never commit your TF state and TF state.backup.
Ignore them?
Ignore them because they contain, things that are potentially dangerous to you. Right, so you see TF state and TF state backup, .terraform. You never commit those, and TF vars. All of these contain potentially dangerous codes. All right, so let's go ahead and do that. So we have this, and we have this. All right, so we're gonna git push, and now we have that. Let's see here. All right, so we have that. Git ignore, everything is good. We have the license. We have main.tf, right?
Are you looking
Um,
at browser?
yeah. And yeah, everything here is cool, right? Um,
Nice. Wow,
awesome.
that was a pretty good tutorial for Terraform, man.
Well,
That
I
was
mean, it's really really basic stuff. We
no, but
did
like
we did
without
nothing here. So
right, without you doing this to like for someone like me to just read it alone and then do it, it would have taken like at least like I would say at least 3 times to 5 times like the amount of time to be spent to understand this. I feel like I kind of got a grasp of this in very short period of time
yeah,
because
and also one thing that with Terraform you have things like count, so you can have like 3 here, and then you have things like um, count dot index. You know what I'm saying? So things like
yeah.
that that are still. So let's do the plan, for example. Now I want to show you something.
Oh, it's like dynamic.
Yeah, yeah, it's a kind of a language here. So well, not a language, but a DSL rather. So you see, for the first one, check it out. So for the first one, it's gonna remove a bucket and add a bucket.
Hmm.
So you see this, it's going to be creative network lambda and creative network lambda 0 because that's the index. And
Yeah,
then it's going to add 2 new buckets like creative
yeah.
network lambda 1, creative network lambda 2, right? So, there are all kinds of things like that with Terraform. So we're not even scratching like, it's not even scratching the surface, right?
Hmm.
We have in the company that I work at right now, um, we have thousands of lines of code of Terraform,
Hmm.
and it's creating tons of resources across all of our environments,
Hmm.
and then you have things like things that save your state, and things that save your state. For example, right now, the state here is local.
Hmm.
And I'm saying, hey, you never commit this state, right? So think about working in a team. If you don't commit that state, and now your peer is working while you're working, then you can override each other's work.
Right.
So that's obviously not good. So there are things like remote state and state locking, and a lot of stuff like that. Really, they've made a really good job with Terraform. And the best thing about it, for me, it's Go. It's 100% Go.
Hmm.
I've patched Terraform. We are working, for example, for right now, at my workplace, we are working with a patched version of Terraform, and not the upstream version.
Okay.
For some bug fixes and things like that did not make their way upstream yet. So it's Go code, and it's, I wouldn't say it's easy to get into because it's a lot of code, but it, if it was, I don't know, like Scala or something like that, I would never even dreamed of going into the code and mingling around. Um,
Mingling around.
so um, so now we have the Terraform part here. Where are we at? Um, so we have creating artwork.lambda. And here, what do we have? So we have the lambda here, right, with the index.
Hmm.
This is the thing we created with the size of the images, right?
Right.
Oh, and we also did the fixtures here to make sure we can. Oh, I remember now. Okay. Awesome. So we have the file here, and then we have the test event, which is what API gateway is sending to the Lambda.
Yep.
We have our yarn. Great. So one of the things here is sharp. and sharp needs to be compiled natively. So one thing we need to do is we need to compile sharp natively in Docker in order to um, deploy it to Lambda.
Awesome. Let's do Docker. Let's get some Docker.
Yeah. All right. So let us go to Docker. So one thing we want to do, if we think about, let me collect my thoughts here for a second. So if we think about what we need to do is we need to do this, right? So we need to get AWS supported Docker. We need to mount the Lambda function as a volume. Install npm packages locally inside the Docker. Tar the files, right? And export to the mounted volume, right? All right. So okay. So let's start here. All right. So let's start here. All right. So we're in Lambda, and here Lambda. Okay, and here we're gonna do Docker file, and here we're gonna do Docker machine create Lambda dash dash driver VirtualBox, and in our Docker file, here's what we're gonna do. So
all right, so
going to do, go.
So this is the part when I play with Docker. This is one part I actually get confused a lot. You know how, like, okay, when you do Docker machine create, right? So right now, like if you do like eval the Docker machine name, then you go into that particular machine, right?
Well, you don't go into that particular machine.
You go into that environment, right?
No. You export some environment variables that proxy your command line to that VirtualBox.
To that VirtualBox, yeah. So, sometimes, for example, when I if I'm inside this repository, right? If I don't do like the eval stuff and I do like Docker image create, it will create the image outside of that box, right? And if I go inside the box, I do eval something inside the box, and I'm in the same repository, and I do like Docker image create, then the image will live inside of the VirtualBox. Like what's the point of I can actually test the image and create the image outside of the VirtualBox. So what's the point of having the VirtualBox at all?
Well, first of all, I don't know what version of Docker machine you have installed and what can happen.
But do you know the situation I'm talking about? Like, do you like? Does it make sense of what I just said?
Not really, but first let me, here's the deal. So if we do Docker machine and Lambda here without eval. I just want to see I just want to show you what happens here, right? So we have a Docker host, and we have a Docker cert path, and we have a Docker machine name. So for you, what can happen is, I don't know how you installed Docker, but what can happen is maybe you install Docker in a way that you have these exported by default in your shell. So if you open a new shell and you do like export something like this, so export Docker host, right? Then you might have some things by default.
Really?
Right? So for me, for example, right now it says, hey, I cannot connect to the Docker daemon because I don't have anything by default in my Docker host.
Like, what if you do Docker images like right now without doing eval? Like, if you do Docker images, what would happen?
No, nothing. So
That's it.
there it is. Just a sec. What did you do?
I just do Docker images. Wait, what happened to the screen? Why is it so small now?
Just 1 second. All right, so.
What? I just see JJJJJ.
Yeah, I know. Just a second. All right, so. All right, so Docker images will give me nothing. It says, hey, I cannot connect to the Docker host again because
that's interesting.
Docker host is nothing. So if you do echo Docker host, you probably have something there.
Echo, wait, let me do that. Echo, what is it? Docker host?
Yeah, echo $Docker _ host, all cap.
I see nothing.
So how did you install?
I used the Docker, like the one that I download from Docker website. You know what I mean?
Yeah, I don't know what that does.
www.docker.com.
Yeah, I don't know what that does.
No, like docker.com.
I don't know. Let's see. That's not how I installed it. So let's see.
What? How do you get your Docker? Like, how do you get?
I have Docker machine.
Oh, I'm looking. I do Docker.
Yeah, I see there is a Mac. Probably they have a better way now to get Docker.
Yeah, we're using different software here. I'm using the one from Docker, the Docker company. You know, I'm using their Mac client to manage all my Docker stuff.
Yeah.
So for you, if you don't eval into a virtual drive, you can't even create images.
No.
Right. Which makes sense. Like for me, that was why it's weird.
No,
because
but that's what I'm trying to see. So let's see what's going on here. So Docker for Mac is easy to install desktop app for building, debugging, and testing Dockerized apps on Mac. Docker for Mac is a complete development environment deeply integrated with the Mac. Yeah. So exactly. So that removes the need for the Docker machine, and probably for VirtualBox as well. So that's interesting. Yeah, I just did not install it this way.
Okay, yeah, that's why. Because the first time I ever worked with Docker, I work in your flow, and then when I was using this, and I started realizing, if I'm able to create like images like in my environment right now, what's the point of creating images inside of like another drive? You know, and it gets confusing.
So you don't need it. But I just haven't installed that one yet. So let's see. So we have Docker here. And then all right, I see it here now. So Docker, let's see what it does.
I'm getting water, so excuse the noise.
All right, so let's see what we have here. Okay, privilege accesses. So let's see, and what do we have here now? Okay, so Docker is starting. Yeah, so now that's what I'm gonna have. So let's look at the preferences here. So start Docker when you log in. We have file sharing, so it's gonna see the files. We have computing resources, so it's gonna give 2 gigs of memory. We have proxies. We have daemons. All right, so now this is starting. Okay, compatible with Docker for Mac. All right. So right now, what's the Docker store for God's sakes? Why does everybody have a store? All right. So now,
Make money.
Docker. I probably need. Yeah. Okay. Got it. All right. So now I have Docker and don't need the virtual box.
Yeah, that's pretty neat, you know. Like you could just do Docker build here, like right here in the repository.
Yeah. 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 So you don't need Docker machine.
Yeah, it's pretty good. Okay, that makes sense. So they just basically build a Docker machine environment in the Docker client, and now that I can just do it anywhere, anytime.
What's the
Much-
Docker store, for God's sakes?
Sell your stuff, man. What do you think it is?
Okay, I see. Like plugin. Oh man,
Dude, this company must be doing really well right now.
Anyway, let's not focus on like Docker the company. So, great. So, let's go ahead and continue here. So we're gonna do from Amazon Linux. And I don't know if that's what I want.
What else can you want?
What I want is I want to check what node is based on. So node Docker. So I want to see what's the base image for node. And this might be good enough for me. So let's see 610 here. So 610 and 610 is from build pack depths Jesse. So this is Debian. And let's see here, Amazon Linux Docker. Right, Amazon Linux container images. No, that's not what I want. There it is, Amazon Linux. Amazon Linux. So this is latest. Let's see the Docker file. So this is from scratch. So
this is the Docker. Amazon is.
So this is from scratch, and then it adds the Amazon minimal. Okay.
What is Scratch? Is Scratch another image?
Scratch is Scratch.
Scratch is nothing.
And
no, seriously, is Scratch
so
like
this is
Scratch?
Yeah, so this is the Docker Scratch. You see this? And explicitly empty image, especially for building images from scratch.
Okay, that's pretty interesting.
So this basically adds the Amazon Linux, but this is weird. Doesn't it build it? What does it do? So Docker file and then cmd bean bash. All right, so first let's see this. So let's do from Amazon Linux and nothing else. All right, so Docker build -t. Let's do cancel dev Lambda something, I don't know, and then this. Right, so it's
All
gonna
right.
send, and then now it's gonna download Amazon Linux from Docker Hub.
Awesome.
So it's gonna pull it.
Man, Docker is just so good.
Yeah, until you go to the edges, like every software. All right, so now let's do Docker images, and we can run Docker run -it cancel dev lambda, and let's do bean bash. All right, so ps aux. So we don't have anything here.
There's nothing here.
Yeah. Okay, great. So we have Amazon Linux now, but what I want to do now is to install Node. Um, so to install Node, what I need is Node GPG key in order to install it. Let's see what we have here in distributions. So we have RPM here, setup 6x. Right, so let's see what we have here. So distro package. Okay, so is this gonna install? Let's see. SRC, what we have here. Build. Okay, so this is, let me see here. Node source is the safest, most secure Node.js platform. Secure, reliable. Yeah, all right. This is, all right. What does this tell me? Okay, node source, Node.js binary distribution. So node source, great, 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 great. Great. So curl and then bash. Okay. So what we can do is
We
we
can
can
write this in
grab this.
Docker file.
Yes, we can grab this and have this. I have actually 5 more minutes, so let's do this raw. And then we're gonna do here. So let's do setup.sh. This. Whoops, that's not what I wanted. That's not what I wanted.
Whoa.
Yeah, just 1 second. Vim is weird like that with pasting. All right, so let's do this. All right, Vim is choking on me. Okay, great. So now this is good. And I think what we can do is we can copy setup.sh to setup.sh, and we can run chmod plus x on setup.sh, and then we can run sh setup.sh. Right? So let's see.
Well, that's pretty smart. That's pretty smart.
Okay, so
Well, it's actually running it.
of course, what do you mean?
Is that one time
Um,
one time copy paste? Are you kidding me?
so one thing I want to do now is run this and do node-v. So
Okay.
wait, so let's do bean bash and node-v.
No, it's not here yet.
So seems like it's not here. Oh, as root to install Node.js. Oh, okay. Okay, so checking for existing. So what I might need is to install GCC and this. All right, so before I do this here, what I'm gonna need is to do this.
Okay. So is like Yum pre-installed with the Linux machine?
Yeah. All right, so let's see this. Okay.
Looks pretty good.
Yeah. So this is gonna download and gonna install. Unfortunately, I have to go now.
Okay.
So we're gonna continue this tomorrow.
Yeah, tomorrow, Friday, I'm good with both.
Yeah. All right. Let's see if we can get something here.
Let's see the result of this build.
So curl.
Okay, it's doing yum install GCC make successfully. Try the node.
Checking for existing installations. Run yum install -y Node.js is root to install Node.js and npm. All right, so now let's do this. After here. Okay, so we have the packages. Oh, this is actually supposed to be installed. All right, docker run bean bash and node-v, and we have
Whoa! Look at that,
node
man.
610.
Look at that.
Yeah, so we have
That's
node
pretty awesome.
610.
That's pretty awesome.
And what we can do now
Dude, that was pretty cool.
all right, so we have that now on GitHub. And we are going to continue tomorrow.
Okay.
All right, bye.
All right.